Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and PaintballProps.com. Today I'm going to show you an extremely simple laser detector circuit or even light sensor circuit using 4 components. And we're going to introduce a fifth, a regulator if you want to. This is a 5 volt circuit because the buzzer is rated for 5 volts. First I'm going to show you the circuit in action, then I'm going to talk about the schematic, then we're going to build it ourselves. What I've done here is placed a 5 volt laser in parallel with my circuit. I'm applying 5 volts from my power supply right here. And this is the circuit. So I've got my transistor, my piezo buzzer, my resistor, and my light dependent resistor, and of course my laser that is external. So if I power it on, this circuit is best used in darkness. Right now we've obviously got some light on it, but not enough light. So I'm going to plug it in, buzzer's going to go off. Place your laser on the light dependent resistor, and if you fix it, once you fix it, you fix it to in place. Then if you break the beam, very easy to make. So let's talk about the schematic and then let's put one together. This is the schematic. We've got a 10k ohm fixed resistor, a light dependent resistor that changes its resistance based on how much light / how much darkness is exposed to it. An NPN transistor, I'm using a 2N2222 transistor, and an active piezo buzzer. Active piezo buzzers emit a sound when the relative voltage is applied directly to it, because there's an internal oscillator that creates the piezo effect that makes noise. A passive piezo buzzer would require that we actually feed it a very specific frequency. So this buzzer is an active piezo buzzer, it just requires 5 volts, because it is a 5 volt piezo buzzer. In any case, we've got 5 volts connected to the positive line of the buzzer, and the negative connected to the collector of our transistor. So what happens is this transistor is acting as a switch. When we apply power to the base, which is pin 2, power will flow through the buzzer, through the transistor, to our DC ground line, and the buzzer will beep. Now when there's very little voltage on the base, this is called the base, and this is the emitter. When there's little power on here, then this essentially closes the gap. So basically we see this. There's no connection between the negative of the buzzer and ground. So how do we want to do this? We want to make sure that in light, when there's light on the sensor, the buzzer is not sounding off. And when there's darkness on the sensor, the buzzer is sounding off. So what we've got here is our 10k ohm resistor and our light dependent resistor. Now, in darkness, in complete darkness, I mean, you can use pretty much any light dependent resistor. They have different values, but most of them will work with the specific circuit. But in darkness, the specific the LDR that I'm using offers about 100 kilo ohms of resistance in darkness, and about 1 kilo ohm in when there's a lot of light, say a laser touching the light dependent resistor. So we've got a voltage divider here. The lesser amount of resistance here, light, the lesser amount of voltage we're going to see at pin 2. If we have a very, very high resistance in darkness, we're going to see a lot of voltage at pin 2. And the reason for this is, say we have 100 kilo ohms here and 10 kilo ohms here. Very little of the voltage is dropped along this resistor, leaving a lot of voltage to be dropped along this resistor. In the case of darkness, where this is 10k ohms and this is 100k ohms and this is 10k ohms, we see about 500 millivolts dropped along this resistor, leaving 4.5 volts to be dropped along this resistor, leaving 4.5 volts here in darkness. And that's enough to power the base of the transistor, so power will flow through the buzzer, through the transistor to ground, completing the circuit, and the buzzer will sound off. Now, when there's a lot of light, say a laser touching the light dependent resistor, in this case, we'll have 1 kilo ohms here and 10 kilo ohms here. And in that case, most of the voltage is dropped along this resistor, leaving very little voltage to be dropped along the LDR, meaning that we'll see a very, very small voltage here. In the light, when this is about 1 kilo ohms, we'll see about 0.5 volts here, roughly 0.5 volts here, because 4.5 volts is dropped along the 10k ohm resistor, leaving 0.5 volts to be dropped along the light dependent resistor. So we'll see about roughly 0.5 volts in light. And that is not enough to power the base of the NPN transistor, so basically no connection. So let's hook this up on a breadboard and we'll give it a try. I should mention, if you want to learn more about voltage dividers, I will place my tutorial below, and so that you can click on the link. In any case, we're going to use this 5-volt laser a little bit later. We'll talk about adding a regulator into the circuit a little bit later. But first of all, let's talk about the components that we've already seen. Our piezo buzzer, you might notice that there are 2 leads on it. One is short, one is long. The long is the positive, the short is the negative. Our light-dependent resistor, right here, does not have a polarity. Neither does the fixed 10K ohm resistor. The 2N2222 NPN transistor has a flat side and a curved side. Right now it's laying on its curved side. The front side has writing on it. So this is how you're going to know the orientation. You can also Google 2N2222 pinout and go to images in Google, and you'll be able to see the exact same things I'm telling you right now. The right pin is the collector. The middle pin is the base. And the left pin is the emitter. So what I've done is I've placed the transistor into a breadboard with the curved side facing the back of the board and the flat side with writing on it facing the front of the board. So again, on the right we've got our collector, middle we've got our base, and left we've got our emitter. So next we're going to want to connect our wires for our power supply. So I'm going to connect ground and 5 volts to this rail. I've connected a black wire to my bottom rail, so that will be our ground line, and a red wire that will be connected to 5 volts on our top line. So now when we connect anything here, there will be 5 volts there, and anything here will be our DC ground line. Now what I've done is I've connected the short pin of the piezo buzzer to the collector, the rightmost pin of the transistor. Now what I'm going to do now is I'm going to take another wire and I'm going to connect the positive, which is over here, the long lead of the piezo buzzer, and I'm going to connect that to the 5-volt line. Next, I'm going to connect one side of our fixed 10K ohm resistor to the 5-volt line, and the second to an empty space on the breadboard. Next, I'll take the light-dependent resistor, connect one side connected to the secondary side of the fixed 10K ohm resistor, and the other side to the ground line. Next, take a wire, connect one side to the ground line, and connect the other to the emitter, the leftmost pin of the transistor. So now the leftmost pin of the transistor is connected to ground. Lastly, take one more wire, connect it between the light-dependent resistor and the secondary side of the 10K ohm resistor, the fixed 10K ohm resistor, and that's our voltage divider pin. So this has a variable voltage on it, and we're going to connect that directly to the middle pin, which is our base. And now we're ready to power it up. Now you'll notice something as soon as I power it up. Nothing happens. Nothing at all. So I'm going to unplug it, and the reason for this is because there's not enough light in this room to bring the voltage of the base down far enough to turn the buzzer off. So I'm going to connect my laser in parallel with my power supply. I'm going to connect the positive of my laser to 5 volts. This specific laser is rated for 5 volts, and I'm going to connect the blue wire, sometimes it's black, to the ground line. And we're going to use that laser and fit the beam directly on the head of the light-dependent resistor. Now you can use batteries to power this laser from across the room, but just for demonstration purposes, I'm having this laser on the breadboard. So now what I'm going to do is I'm going to turn on my power supply, and you'll see the laser powered. There it is. So there's a laser beam, and I'm going to put the laser beam on the light-dependent resistor, and it stops. Now obviously it's not ideal to have it floating like this. You want to have it fixed on the light-dependent resistor. As soon as I break that beam, so there you have it, an extremely simple and extremely inexpensive light sensor / laser alarm. Now let's add a regulator into this equation. What we've added here is a 5-volt regulator. This is a 78L05. It actually has the same pinout, same package as the 2N2222. Oh, and again, so what this does is we can feed 9 volts into the circuit, but we need 5 volts to power the circuit, or else we'll hurt our buzzer. So to regulate down to 5 volts, we need a 7805 5-volt regulator. 78L05 or 7805. 7805 regulators are much bigger, and they are meant for higher power applications. This can source 100 milliamps, which is more than enough than we'll need. In any case, so we've connected the positive of our 9-volt battery to pin 3, which is our input. So this is our V in, pin 3. We connect the ground of our battery to the ground line, which means that whenever you see this symbol, it means that they are interconnected. So this wire is connected here, is connected here. Pin 2 is ground, so we have to connect, again, this pin, this symbol, to these lines to complete our circuit. And lastly, we take pin 1, which is our output, our V output, regulated 5-volt line. We connect that to the power supply line of our circuit. And so now we can safely use a 9-volt battery with this circuit. So this circuit will take 5 volts. This circuit takes 9 volts and changes it into 5 volts. So let's introduce this into our circuit. Actually, what we're going to do, we're going to use our power supply and not a 9-volt battery here, but what we're going to do is we're going to have to change where our laser is, because right now we've got our laser on our power supply line, which is rated for 5 volts. But now we're going to change our power supply to 9 volts, and that's not safe for the laser. So we have to connect our laser to the 5-volt line and to the ground line. So red wire of our laser to 5 volts, and blue wire of our laser to the ground line. So the front of the 7805 has writing on it, and the back is curved. So I've done the exact same thing I did with the 7805 that I did with the 2N2222 transistor. So the curved side of the regulator is facing the back of the board, and the flat side with writing is facing the front of the board. So our input pin, our positive voltage pin we're going to connect 9 volts to, is pin 3. So we're just going to place a red wire there, and we're going to connect power to this line later. Our second pin is our ground line, and we're just going to connect ground to this line later, this black wire. However, we also need to connect the ground from our ground line to the ground pin on the regulator, the middle pin, so that all of the grounds are connected to each other, just as we talked about in the video. Lastly, what we need to do is we need to connect our pin 1 to the 5-volt line. Needed to find another red wire there. So pin 3, or pin 1 rather, our output, our regulated output, will go to our 5-volt line. Now let's power it up. What you can do now is you can actually power it up and test the voltage on the 5-volt line and the ground line, between the 5-volt line and the ground line, to ensure that there's 5 volts. But basically, I know there's going to be 5 volts on that line, or else we're going to damage the buzzer almost immediately, and we're going to fry the laser almost immediately. So let's just plug it in, and I expect to hear the buzzer start buzzing and the laser to turn on. Success! I've got the laser pointer at the LDR. And that's it. So I'm going to unplug power. This circuit works great in the dark. You can use the same laser. We sell them at engineeringshock.com, or any laser you might find around, even a laser pointer. You can use 2 AA batteries in series, anywhere from, some lasers are rated for 3 volts, some for 5. These are 5 milliwatt lasers. Very, very, very simple circuit. You don't need the regulator as long as you have 5 volts. In fact, if you have, you can probably power the entire circuit off 3 AA batteries in series. If you have a 3-volt buzzer, then you can use 2 AA batteries in series, which will offer you 3 volts, and that will power the entire circuit. So hopefully you found this somewhat educational. I had fun making the video, and I hope you enjoyed it. So thanks for watching, guys.